Good evening, all. Thanks for coming. It's my pleasure to welcome you all from the entire MOI team. My name is Anantha Krishnan. I go by AK. And my Web3 introduction. How many people are here from Web3? Okay. I'm going to break your heart. I'm a Web0 OG. So how many people are not from Web3? Anybody? So what do you think OG is? Huh? So, original cap. Okay. So was that from a non-Web3 audience or a Web3 audience? All right. So who is a technologist here who is not in Web3? Anybody? You don't have to be shy. Okay. What is Biddle? So look, so Web3 is very clear. We are guys who are very clear, very unambiguous, very practical. So we call ourselves OGs. We make bills, biddles, and we market only through memes. So, having said that, I started off my career building programs on mainframes. I'm sure Professor Pandurangan recognizes it. I don't know how many other people have worked on it. So we used to put input into punch cards and then give it. And we had to be very careful because you don't get multiple attempts. The punch card reader, you used to be very unhappy if you did that. And then we used to get the results maybe in 2 hours, sometimes overnight. It used to take a couple of hours to get the results. So when I started Web3, I felt right at home. Certain blockchain takes the same amount of time, today. So I feel right at home in Web3. I feel how it happened in mainframes happening today. And when I came to this stage, I was wondering, I'm a Web0 person working with a lot of, all my team is Web3 resources, trying to make Web3 better and trying to explain it to a Web2 audience. Very interesting combination. So the other thing is, those days we used to have relational databases, hierarchical databases, intranets, Foxbase, Sybase. Quite confusing. And I find Web3 to be I feel at home with Web3 with all private nets, public nets, enterprise blockchains, shards, roll-ups. So I feel exactly the same way how I felt. So I'm wondering what happened in the last 50 years. We are at the same place or what? It's a very interesting question, right? So I thought internet was supposed to solve all the problems and level the field. But it looks like we are back to where I was started. So it is taking the same amount of time and sometimes to get our work done. It probably cost the same amount what it costed 40 years back. And then you have the same level of complexity that we had then, we have today. So that's the thought I had when I walked up. So I thought, let us take a journey around first what technology, right? How technologies evolve, so that we know where we have come from before we can know where we need to go, right? So that's the foundational approach. And this title, Humanizing the Net, it will grow on all of us in the next 20 minutes. Looks like a motherhood and apple pie statement at this point. Nobody can be against this statement. Everybody wants to humanize the internet. And I'll try to walk you through what we think it means and what we have done to make it relevant for this. What does it move, man? Yeah, right. You want to press? Okay. So the digital world is evolving, right? So I think it's been evolving from the 50s. So if you look at those days when mainframe got started, it was all around your ability to manage an account. Technology was primarily about process efficiency, right? So we didn't anything more than that. We print pay slips, payrolls. So account was your primary driver. Efficiency was your game. And if you want to think of the business model, it was all about a licensed business model, right? That was the kind of user had no input into it. The idea of customer did not exist. So this happened for the first 20 years. It was all about automation and efficiency. Then if you look at it around 1970s or so, you had TCP/IP come in, right? So that changed the game. So previously, I don't know how many of you worked on dumb terminals. They're pretty large, and you want one of them landing on your foot. They're pretty large. So, but then no two of them could talk to each other. One machine couldn't talk to each other. So what did TCP/IP do fundamentally? It allowed machines to talk. At a very high level, that's what it did. If you break it down, it allowed machines to talk. Now, when machines started talking, previously, AK was in application in one computer, AK was in another application in another computer. There's no way to connect both of them, right? You can't build an application which talks to each of them because the computers don't talk. So, come TCP/IP, this whole idea of interconnected computers, right, allowed you to get to this idea of a customer. Very nice idea of customer which happened. And many idea of a customer came in, idea of a platform came in, and your value driver became total customer value, and your business models moved on from more like GMVs and platform fees, things which are more relevant to a customer. And we have seen that evolve in the last 20, 30 years, right? We got all the way from Web 1 to Web 2 and brilliant stuff. So our lives have been changed quite a bit, right? We no longer need to worry about a lot of things which we had to worry about before. Efficiency gains have been enormous. So then, and we ended with the Ubers of the world, the Facebooks of the world, right? The Googles of the world. Tremendous progress. Then comes Web 3 now, right? Today's Web 3. And we want to decentralize the infrastructure. They're saying, okay, now why should computers talking is great, but can computers talk like human-like fashion? So if you look at Web 2, it's all about client-server, right? The computers talk, but then there was a client and there was a server. So can you get to more of a peer-to-peer model where computers can't talk to each other like a human-centric model? This started from Napster, so quite a few things happened early on. So this has been going on for a while. And the culmination of it was Bitcoin to say, how do I do a value transfer in a peer-to-peer manner, right? That was the whole idea of, so when Web 2 to Web 3 is peer-to-peer conversations as opposed to client-server conversations. So can machines talk to each other in a peer-to-peer way? Still be connected overall, right? The point is that it's not a point-to-point. Overall, I can discover whomever I want in the network, but I can have a peer-to-peer conversation. And Bitcoin came in and said, how do you do value transfer in that kind of an environment? Now, that's great. So the key question is, if all of these things have happened, we went back and asked, what should change, right? It has improved your quality of life. What should change, right? And this is the question we asked in 2017. And if you look at it, how has technology changed? You now eat your lives using technology. If Zomato servers go down, maybe half of us will go hungry. Uber servers go down, we may not be able to get home. And of late, if ChatGPT servers go down, we may not be able to write. So that's where we are heading, right? So technology is no longer a supporting artist like the way it was in 1950. It is becoming a main artist in our life. This was the recognition that we had in 2017. The way I communicate this is, we are no longer connected by technology, which was happening. Now we operate by technology, foundationally different. Now, this creates lot of possibilities around and lot of complexities as well, right? So when you live your life, can you put the next slide in? So we are no longer connected by technology, we operate by technology. So at a very high level, the use of the tool has changed, but the tool itself has not changed for the last 80 years, right? So dimensional shift has not happened. So this, when you live by technology, what is happening? Let me give you 5 examples, and then we'll try to see what I put out there. Assume I have an 100 rupee note here today. I give it to different people with different needs. Is the 100 rupee same value for everyone? No, right? So when you somebody who is in need, it has got a different value. So let's keep that example in mind. The second example is, assume you meet how do you build a relationship with a new person? The first time you probably say hi. The second time you probably shake your hands. The third time you probably give them a phone number. And let us look at a third example, right? Now I'm talking here. So what I communicate here is what I want to share with you. The kind of privacy concerns I have, what I want to share with you is very different. Assume I want to talk something a little bit more sensitive from a design standpoint with Manish. I would go and talk about this in a coffee shop. And if I really want to get hush-hush, I get into a room and have a private conversation. And the last example I would give you is, say if you're going to go pay for a coffee, you would expect just 100 rupees in your wallet, and you want that to be done very quickly. Whereas if you were going to buy a house in Beverly Hills, you work on it for months, you take your time, you validate the process, and you want to get it. You want the trust to be very high. You want to make sure that it works. Now, what is common in all of this? Can anybody answer? It is completely personal and participant-centric, right? So how do today's computers deal with it? Can they make differentiation? They can't. All of them are information transfers. Today's computers work on information transfers and not on value transfers. And human interactions are primarily value transfers, which fundamentally means it is participant-centric. So what we called as 2017, when we coined this word called digitally interacting world, that's where we are going, where technology is a foundational part of your life. It's not enough if you have peer-to-peer communication. That is just an information transfer, which is what is happening in many of the technologies today. But you don't have the participant fundamentally be part and control that interaction. So, literally, it is your values, but you don't have a seat at the table. Imagine this. Would you ever do that in your life where somebody else drives this behavior? It's not possible, right? So, and the reason is not because somebody was nefarious who wants to do this. It's because the use of the technology has changed, but the technology has not changed. We have allowed technology closer and closer into your life, but then now it cannot be more app-centric. It has to become participant-centric. This is what we call as human-like interaction, the ability for the participant to fundamentally control and manage your interaction the way you want. You want the coffee transactions to finish in 30 seconds, and you're willing to take additional risk. Otherwise, the coffee will get very cold. You can't say, I need 25 blocks of consensus before I will give you this sip of coffee. Whereas for a Beverly Hills purchase, I am able to wait for 2 days if I want, right? That a lot of people verify the transaction so that you have a higher degree of trust. So the kind of personalization and participant centricity that you want to have, you don't have in technology. And this is what we call as enabling human-like interactions. This is what human centricity is. Go to the next slide. So, just take me back to the previous slide. All right, that's fine. Next slide. Go to the next slide. So, let us take an idea of how we have changed this, right? We will worry about this stack a little bit later. But how do you introduce participant foundationally into computation is the next question, right? So, we have said today's computers at a fundamental level doesn't allow participants. You don't have a seat at the table, right? Now, how do you do that? So to do that, you need to go and understand at a very high level what is the framework for today's computational model, right? It's based on an idea called Turing machine, which is the foundations of computers. It takes 3 inputs. I'll simplify this. It's a very simplified version. Professor, sir, please forgive me if I'm making any mistakes here, okay? So there are 3 inputs that it takes. 1, where is the process happening? What is the computation working on? How is the computation done? I'll repeat it again. Where, what, and how. What is missing? Dimension of who is processing the computation is not fundamentally part of the algorithm, right? If it is not part of the algorithm, today you are an attribute for computation. You cannot enable the computation because you are an afterthought. So as Turing describes this, I won't go, it is discrete, finite, and controlling. The 3 words that he uses, okay? Discrete, finite, and controlling. Would you define human interactions like that? It should be continuous, infinite, and personal. That's the foundational problem that we have. Until we solve this problem, you're not going to be able to an environment where participant is a foundational dimension of computation. And that's what we have done using this idea of a K machine, where we have built participant foundationally into computation. You have a seat at the table first, right? So this new intelligent machinery that we are talking about is contextual, right? It is context aware. And let me give you one more example and I'll close this topic. So I was dropping my daughter off in a university in the US, and robots, really sophisticated robots, which deliver food all through the campus. Brilliant. They wait for the red signal, they wait for the yellow signal, they cross when it is safe, they very, very extremely nimble, go around blocks. But I had this thought exercise on, are they truly intelligent? So it's a question, right? Do they exhibit human-like interactions? And My thought exercise was very simple. So if there is an yellow signal, okay, and two robots come in, will one of them wait while the other cross? They will all be interacting with everybody, right? That doesn't happen today. It may be undeterministic, but predictable. Right? What I mean, both of them may run, both of them may stop. But the true contextual compute machine, based on the interactions that you had in real life, right? You have made your judgments based on delivering food. One of them will wait, one of them will cross. The second model is what we call as in contextual compute. The first model is what we call as in contextual intelligence versus systemic intelligence. So we have built on this idea and built a framework called K-Machine, which foundationally introduced participants into computation. You have a seat at the table first. Okay? That's the first stack, contextual compute. Want to go next one? So this is what I talked about, the truth of intelligent machinery, the new truth of intelligence, systemic intelligence versus contextual intelligence. New dimensions of participant into computation. And I'll talk about the last one at the end. Now, yeah, move on. Leave it here. That's fine. Just keep it at ISM, okay? So, how do you define intelligence now? In this new contextual compute framework, how do you define intelligence, right? So, in the old framework, intelligence is defined as something which is discrete, finite, and controlling. It happens after the knowledge discovery has happened. We define intelligence as something which happens only when you interact. The act of interaction defines the intelligence. If you want to think of another example, assume you have a machine today which measures heights and weights of people, right? And the average height is 5'5" and the weight is 300 kgs. So a program would say the intelligence would be 5'5" and 300 kgs. The new contextual compute model, assume a small person, 4'8" and 150 kgs, interacts with this machine. What would be his conclusion? Will it be an average height and average weight? His conclusion would be, his value would be, personally, he would say it's a big person, right? Whereas somebody who's 6 feet tall and 400 kilograms will see it as a small person. So the whole idea is intelligence is in the act of observation. And after the act of observation, what you have is only knowledge. This is the foundational change that we are trying to bring in. So no intelligence exists without an interaction. So that's why the interaction state machine. So when two people interact, so it's always networks, right? Networks, people interact, it's a peer-to-peer interaction model. So we have an interaction state machine built on top of that. So since values are personal, we need to transfer values. At all the time, we need to transfer values. And then interaction state machine allows peer-to-peer value transfer, because human centricity is all about peer-to-peer value transfer. And we have built a state machine replication. Obviously, if you have billions of nodes, I'm sure all of you got a diary which says millions of nodes and billions of transactions. So if you build it like today's internet, you will have millions of nodes. So obviously, all the you and I interact with the transaction, the result has to be submitted across all the networks. So you need a state machine replication technology, which is the ability for you to transfer that value across multiple devices. So we built a state machine replication technology foundationally built for peer-to-peer systems. Okay, that is interaction state machine. I won't make it very detailed, but then I'll highlight some points. I already told you the difference between information and value. So in today's, most of the distributed systems, if you go and ask a distributed system, the question is, what is A-case balance? So what is the true question that we want to answer, or even in a blockchain? What is A-case agreed balance? I do not know whether the balance that you give me is the finalized balance, right? in a large network, that's the only question that you have, right? So what we have done is this idea of agreed balance. This agreement is statefully maintained. So every object in interaction state machines or a network level object. Today in computers, all objects are node level objects, program level objects. So using this idea of context, which is the first time introducing that word, which allows you to share in the network your final value setting. So the agreed value setting. So that is available for every object. So what does that do to the overall solution? Today, if me and Professor Pandurangan are doing an interaction, at the same time, we can bring values that are specific to me, controlled by certain parts in the network. Pandurangan can do the same thing, and we can execute an interaction while Manish and Rahul do an interaction. The ability to do controlled peer-to-peer interaction where you manage the compute is allowed by this idea of interaction state machine. So, and we have also created something called context and context objects. So context is kind of this, your intermediary in the network. Let me take 1 minute to explain what it is. Let's go back to the previous peer-to-peer human-like example. If you 100 rupees or I give you a bushel of wheat and you give me a card. And it's just between both of us, then there is no need of recording this, right? It's a personal, values are foundationally personal. Nobody needs to care about it. As long as I'm happy, as long as you're happy, things are done. So why does the recording happen? Because the personal value needs to become a general purpose value, right? Some people need to agree to say that this is something that AK and professors are did, right? That needs to be recognized. Now, the point is, who does that recognition? Who is the intermediary who does that recognition? Right? That's the foundational question of all of distributed systems, all of blockchain is trying to do, all of value networks are trying to do. And today the model is the system decides. The entire network decides that this is the truthful transaction which can be written somewhere on a book. Wouldn't it be a lot more easier if me and Pandurangan sir, some proxy of me and Pandurangan sir, can write into the network without burdening the entire network, while that we fly? Wouldn't that be a much better model, right? Isn't it? So if everybody assume that if everybody need to come to witness this and write this, this is going to be a very costly operation. So why would, so in real life, what do? You bring your co-signatures or your friend, your known people. You don't call a guy, if you're doing a transaction in Bangalore, call a guy in San Francisco whom you don't know to be part of validating that, right? We don't do that in real life. So that's what's happening today in distributed systems because there is no recognition of the participant. So context is think of it as your guardian or the intermediary in the network who allows you to perform this transaction. So the guardian comes with you so that when two people, peers, are able to transfer value, two other people have their own separate guardians who are able to do the transaction. So this eliminates a lot of burden, it increases scalability, flexibility, personalization, and all the good stuff. So context is your guardian and primary representative in the network, if you want to think of it. So that's why it's a contextual compute machine. It allows you to manage your values in the network. So, and at the end of the day, if you want to look for a definition, ISM is a peer-to-peer state machine replication technology. So whoever wants to talk more about it, I will be more than happy to do it. But a very high level, it allows you computation and value transfers at a peer-to-peer level. That's how human beings operate. Human beings don't operate, call everybody and try to make a value transfer, right? So that's foundationally is not going to be able to create a sustainable digitally interacting society. Next slide. So I will not spend a lot of time on this slide. I want to spend a little bit time on use cases. So how have we brought ISM to life? So we have built a protocol called IFPCP, and that's like the TCP/IP for the state management. Today, TCP/IP does information management. I told you informations are different from value. I demonstrated that. So how do you do state management in a way which works? Because now I deterministically know who are all the guardians for my value, right? Which is called context. I am able to transfer that context across the entire network. And because two peer-to-peer participants can achieve finality, which is the interaction finality, state management and modification process, we have a very robust framework where you can have millions. Interoperability has been a big problem in Web3, primarily because your consensus algorithm is not centered around the participant, it is centered around the network. So you can't take the entire network and move to another network. Such a thing is not possible. So we have bite-sized and compartmentalized this idea using context. So when I want to move from one network to another network, basically the transport problem that you typically have at the state level is enabled through context. If my context goes to the other network, I know who the guardians are. So they can all come to the party to make a value transfer. And we also made the agreement, writing in the book, at a peer-to-peer level, right? The consensus also happens at the peer-to-peer. Not everybody in the network need to be part of that decision making. So both of them together give you a very good framework and a model and a bunch of capability which will allow you to do billions of transactions across millions of nodes. So the reason how we are able to do that is foundational participant centricity into computation. Using all of, we have an open network implementation called MOI. It's a global value network. So before I go to what MOI is, let's go back to a little bit on what the problems are. You can be here. What the problems are in the blockchain world, right? So I talked about Bitcoin. Bitcoin as the paper says, it's a peer-to-peer electronic, I forget the name, electronic system, right? Electronic money system. So the key operative word is peer-to-peer. That's what makes it decentralized, right? Because otherwise, computers if it was a client-server model, it's dead. I told you peer-to-peer is where the decentralization started, at least at the infrastructure level. Now, Bitcoin was a phenomenal success where you're able to do peer-to-peer value transfers for a single currency across anonymous validators in an open network. You got to process that. That's just a mind-blowingly tough problem, right? You're using anonymous validators because anybody can become a validator in an open network, and I guarantee the value transfer, right? So that's just a very, so it worked for one asset. Now, after that, there are attempts to do multiple assets. So there are many people who came in and said, we'll do multiple assets. There was an attempt called Colored Coin, which was trying to do multiple assets, multiple cryptocurrencies on the same blockchain network. And the culmination of that was the 2014 effort to, when Ethereum came in and did a programmatic way of value transfer for multiple cryptocurrencies in the same network. But the problem was, in that exercise to make it general purpose, we moved away from a peer-to-peer model to an app-centric model. You're no longer a peer-to-peer because your compute still is at an app level, right? So what has happened is the apps have become the bottleneck. Now, as the digitally interacting world has moved, it was not as it started in 2018. Now you don't want to do thousands of cryptocurrencies. You want to do trillions of digital assets. Every digital asset has got its own preference because in real life, you have your own assets and values. You need dynamicity, you need personalization. So it is becoming very participant-centric. It is going app to participants. It's moving from thousands of cryptocurrencies to trillions of digital assets. So that has created a problem because your other aspects of a value transfer, only the state management or the data management in Bitcoin was peer-to-peer. But the other aspects, the execution aspect and the compute aspects were still not peer-to-peer. So that's so this explosion happens of participant centricity and digital assets. What has happened is you've got scalability problems, bottlenecks. When you scale the network, you need to reduce the performance comes down. So you need to get a relatively layer 2, shard chain, side chains, rollups. The complexity builds. So we get walled gardens of layers of capabilities that you drive. Now that's not a sustainable end state. When you get trillions of assets, are you going to have trillions of apps? So the world is moving to a participant-centric model, and so we need to have a differentiated answer. So the way we have done is MOI is foundationally participant-oriented, so we'll see it in the demo very quickly, and interaction-centric. So every aspect of the stack, data management, compute, and consensus, all of them happen at the peer-to-peer level, right? So it's not app-centric, it's participant-centric. Assets, logics, and files. If you look at it, most of the protocols today don't have file management capabilities at all. So you can't read a file, write a file. Such a thing doesn't exist. But in MOI, you can do that. But then asset logics and files are native values. I'll take 1 second to do that. Today, if you, how many of you know if there was a hack which has happened on Ethereum itself? Ethereum itself. Ethers was stolen from Ethereum. So where does the hacks happen? In the smart contract and bridges, correct? So the problem is your application tokens have second order security. They are not native assets in the protocol, right? Bit get hacked, Ethereum doesn't get hacked, your app tokens get hacked. The reason is they are not native assets. They don't have the same first order security like the native token. So in MOI, all assets, logics, and files get the same first order security of your protocol token, primarily because it's participant centric. Everything is very important point that increases enough security. And then we also built quite a few number of engineering elements. I don't know how much time I've left, but then we have something called POXT, which is a proof of context consensus that we have built, which works at the interaction level. PISA is a new execution engine that we have built ground up, which does interaction execution. MDAG is a completely new data structure. It's a multi-link composite DAG, which allows both security and scalability. If you know, most of it were in L2. When you scale in Web3, when you scale, the security comes down because you'll have to break up the network. Here you can do both through this idea of MDAG. And we have a new Sybil resistance mechanism around Senatus, because if you look at it, the resources that you use for Sybil resistance cause a lot of issues around sustainability, right? So we have used a very interesting Sybil resistant resource around the participants themselves, which makes sustainability a very simple problem. We don't have sustainability issues. More importantly, it trends towards decentralization globally over time. And Fulcrum is your load balancer. The other problem, if you look at most of the Web3 networks today, is you have 1 million nodes, but then obviously maybe 900,000 of those nodes don't get any work. What is the point, right? So how do you have a load balancer which in a decentralized way can distribute work across the entire network? Not feasible in today's Web3 network, because how can the system garner the system itself? It's a very difficult problem, because we have context and participant centricity. We can fork off the network, split the network in such a way that different participants use different portions, and so everybody gets work. So it becomes very democratic as well. Benefits and use cases, one flat chain. So it may be hard to believe. We can demonstrate that this can be done in one flat chain. So you don't need sharding, side chains, you don't need rollups. So it makes it very simple. So obviously we don't need bridges. You don't need smart contracts most of the time. So many of your security vulnerabilities go away, because everything is participant centric. You have a new dimension which allows you to do that. Very secure, because it's interaction centric. It's not a global, it's not a computer which needs to work everywhere. It's very interaction centric. So we have many interaction types. Manish will go through that, so that for people who are from the other world, or the earlier world, it is like your ODBC. I was initially part of the team which built Oracle. So the ODBC drivers, right? So it's like you execute, your state manager is bite size. So you're able to control that, right? So it's interaction centric. And so with this model, you can build a true global computer, which was the intent when this all got started, right? So it's not so we can build a true global computer. It's possible. And scalable, because it's a fully peer-to-peer network. State management, execution, and consensus, all of them are peer-to-peer. The starting point was Bitcoin, where they tried the state management at peer-to-peer level. We have completed the dot, and made the other two peer-to-peer as well. So that makes it hyper scalable. You can do millions of transactions across billions of transactions on millions of nodes, and fundamentally there is no constraint at a design level, which will obviously we'll have to make engineering improvements from a design standpoint, from a conceptual standpoint. It makes it very it makes it hyper scalable. And finally, sustainable. This is a question: when you go there, how do you sustain? So no specialized hardware required. It can even work on an very simple Raspberry Pi. And as I told you, a new Sybil resistance. So you don't have to burn forests to make sure that the transactions are done. So it's highly sustainable. From a use case standpoint, safe DeFi. So DeFi is a big thing. Most of the smart contracts have become banks now. So, right? So you move from one intermediary to another intermediary. So how do you do safe DeFi? Because the values don't sit at the smart contract level. It's at the participant level. Only the compute sits at the smart contract level. So a hack into the smart contract doesn't open up all the assets of all the participants. Decentralized identity is another use case which work on adaptable storage management, because that's a very interesting use case for enterprises. As more and more people move to the shared infrastructure model of using cloud to harness the economies of scale, what happens is you still need to be able to have your own personalization on a shared infrastructure. How do you do that? So that's a very hard problem. We do that based on this idea of context, because it's customized and flexible. And we also have a practical Web 2 to Web 3 migration model. So one of the largest problems of transformations of this magnitude that I have learned is change management. How does it work? Web 2 is real. Trillions of dollars of investments have gone into Web 2. So you cannot say, hey, okay, move over, here comes Web 3. Such a thing doesn't exist. I know people still using AS400 and mainframes, believe it or not. So there is always a change management path. So we have practical Web 2 to Web 3 migration path. The way we have done that is decoupling storage, identity, compute, and ledgers. So with that, we are able to practically migrate from Web 2 to Web 3.